Ingatkan. Okay, sorry. Okay, dah record. Baik. Dr. Tina ni merupakan seorang bagi saya lah sebab saya follow dalam YouTube juga seorang international speaker lah untuk IoT ni sebab saya pernah follow tengok doktor bagi talk dekat India kalau tak salah kan. Jadi bukannya orang yang calang-calang dalam bidang IoT ini dan IoT ini adalah satu bidang yang menarik sebenarnya. Dalam kita tak sedar pun kita ada yang pakai contoh pakai IPTV kan, kita pakai apa IP kamera dekat rumah, kita ada smart lighting kan. Kita tak tahu apa yang doktor nak bawakan pada kita, mungkin intro cerita tentang IoT ni, tapi yang pentingnya kita sebagai student pelajar IR 4.0 ini, benda ni walaupun bidang kajian kita bukan IoT, tapi saya kira ini sangat pentinglah untuk kita walaupun bukan mendalami sedalam-dalamnya, sekurangnya kita tahu surface, kita tahu latarnya macam mana supaya nanti bila kita dah habis tamat belajar nanti ataupun dah kembali ke tempat kerja kita nanti kita boleh dirujuk lah ataupun kita tidak kata apa tergagap lah untuk menjawab apa itu IoT. Jadi saya kira ini bukan topik yang biasa, ini topik yang menarik yang patut kita tahu. Dan sebelum Dr. Tina nak bentangkan, saya juga ingin Dr. Tina perkenalkan sikitlah latar belakang apa yang doktor belajar kat mana dulu kan, supaya mungkin cerita doktor ini boleh menjadi inspirasi kan, jadi orang kata apa semangat kepada kita yang baru-baru nak berjinak nak belajar ni kan, yang buat research lebih-lebih dalam bidang ni lah kan. Saya tanpa membuang masa, saya mempersilakan Dr. Thinagaran untuk doktor atas keselesaan doktor lah, doktor nak deliver dalam English ataupun dalam Melayu kan, jadi nak mix ke terpulang kita alu-alukan apa saja. Baik, dipersilakan doktor.
Selamat sejahtera and selamat pagi semua. Terlebih dahulu saya ingin mengucapkan terima kasih kepada Dr. Big dan penganjur Innovate FPP kerana sudi menjemput saya untuk menyampaikan topik IR 4.0 talk series. Saya sini first time saya bagi talk untuk pelajar FPP. Sebelum ni kebanyakan talk, even syarahan untuk industri dan juga community university, tapi saya this is the first time untuk FPP. So terima kasih di atas sambutan yang diberi. Alright. So hari ini saya lebih kepada tadi tak tanya pasal background saya. Saya memang graduan hardcore UPM. Hardcore UPM maksudnya saya bachelor di UPM, master pun di UPM dan PhD pun di UPM. Saya bachelor dalam kejuruteraan sistem komputer dan komunikasi, then grad master science sistem cerdas di Institut Teknologi Maju ITMA, dan kemudiannya PhD sambung di institut yang sama, di Institut Teknologi Maju di UPM. Kalau ikut kalau nak tahu mengenai kronologi kerjaya saya, selepas PhD saya sambung sebagai postdoc, pasca doktoral di Fakulti Sains Komputer, dan seterusnya menjadi pensyarakanan di jabatan yang sama. So bidang pengkhususan saya ialah dalam sistem terbenam, embedded system dan Internet of Things. IoT macam Encik Mazlan respon tadi, sememangnya IoT ialah pillar dalam IR 4.0. It is considered as one of the pillars in 4.0. So cuma kalau kita tengok dalam kurikulum, IoT lebih menonjol dalam sains komputer. Walaupun diguna pakai dalam semua bidang, semua domain, tapi lebih menonjol dalam bidang sains komputer. Sebab dia punya fundamental knowledge is from the computing. So hari ini saya akan cuba kongsi bersama anda semua berkenaan dengan Internet of Things, driving the digital information transformation, and bagaimana sebagai pelajar dalam pendidikan, I mean in the background of education, if you want to use IoT, then you might have some clue or hint how to get started. So lebih kepada santai. Jika ada soalan nanti boleh tanya saya selepas talk nanti. So boleh saya share screen, Cik Islan?
Boleh doktor, saya dah allow.
Boleh nampak slide saya?
Boleh Doktor, jelas.
Okay. Terima kasih. Okay, so Internet of Things driving the digital transformation. Okay, kalau kita tengok the topic today, okay, saya akan share sedikit mengenai introduction and why IoT is important for digital transformation. Some use cases for the beginners. Okay, so those who are new to IoT, okay, you will learn some of the fundamental concept. Okay, and then some of the challenges, okay, the road ahead, and then standard factors. Okay, so we know that everybody is talking about IoT, okay, and it is not new. It has been there since 1998, okay, especially when it was first coined by Kevin Ashton in a presentation in 1998. So till from 1998 till today, okay, we have seen that IoT become a strategic technology trend. Although not so significant, okay, if you compare with machine learning, okay, like I believe Dr. Ezzam has spoken about machine learning, okay. So machine learning is more likely a branch of AI, but IoT is more likely a technology by itself, okay. So it's a mega trend, it's a game changer that will give some significant impact. And industry, not only in Malaysia, but worldwide is seeing that as a $1 trillion market. It just, we are not seeing much of the product because the growth pace is taking very slowly. But I think in the next 5 years, we will see more and more IoT product around us. So before we go deeper, I think it's very important for us to understand about the IoT. What is IoT all about? And normally when we talk about IoT, it's about objects. So what are these objects in IoT? Okay, and if you see that, we can categorize IoT objects into 3 categories. Okay, so kita boleh masuk dalam 3 kategori, okay, objek IoT. The first is passive object. Passive object ni is like our metric card, okay, or any smart card, okay, that you have, which have some pointer or some information. Normally, the only thing that you can extract from this passive object is like information and location. So I think we can say our touch and go, okay, touch and go card that we use in the highways, okay, that is actually a passive object, right? Then the second category of object is reactive objects. It's more likely a common IoT object around us. So I think if you look at a switch that can turn in or turn off, okay, smart meter, right? Like your aircon, right? When you have an on and off button, right? This is what we call a reactive object, meaning that when you press, it gives you a triggering action. So reactive objects memang banyak di sekeliling kita. Okay, there are a lot of reactive objects around us. So contohnya home automation like smart home. So when you have like a auto gate, okay, at your home, when you have a CCTV, okay, IP camera, okay, and you have like a smart card reader, okay, all these are actually reactive objects, right? The third category, which is the biggest challenge, and this is the final, the real philosophy of IoT, is we call as autonomous object. So autonomous object is something that an IoT object that should do its data collection autonomously without human intervention. So just like vending machine or intelligent fridge, okay, you might heard about intelligent fridge, like okay, like you have some item in the fridge and then it's going to expire. So the fridge should be sending an email to you and then telling that, okay, please go to the nearest Big Mart, okay, please go to the nearest Pasaraya to order the items, right? There should be some intelligence mechanism embedded within the object. So dalam the philosophy of IoT, we are looking forward this kind of autonomous object that will do things for us without a little human intervention. Okay, so the first 2 object is fine. Okay, it's very common, but the third is like we don't see them much yet, right? So that is the current scenario or the development focus worldwide. Okay, so when we talk about object, okay, there are some things that we have to consider. Okay, contoh object ID, okay, because you are talking about thousands or 2,000s of objects, not 1 or 2, right? So if you're talking to install, okay, let's say for example in faculty pengajian pendidikan, we want to turn the faculty into a smart building. So you want to have IP cameras, CCTV, okay, various IoT objects. You have to consider about the ID. How do you manage the ID? So that's the first challenge. Okay, especially when you have many thousands of sensors. Okay, it's not easy to manage the identity. Then the attributes. Okay, what type of sensors that we're going to use, right? And what does it measure? We have to refer some standard. Okay, different countries have different standard. Okay, and then location or other objects, relation attributes, authentication, okay, in terms of security. So these are some things that we have to consider before we look into the use cases. Okay. So the definition, okay, if you look at most of the consortiums, right, organizations, they look IoT as infrastructure, okay, but apparently it's more than that, okay. Although we do agree that the IoT carries the notion of global infrastructure, it's like a form of communication that involves one or more entities, right? But these are just the generic definition, right? And for consumers like us, okay, we want to see something that can converge the technology, the communication, the data, and try to relate with us, the public. Okay, so that's what we want to see in IoT actually, and this is going to influence the industry in coming years. And normally, okay, consumers like us, we don't want complicated things, something that very easy, user friendly, right? So when we talk about user friendly, there should be some humanization of technology, something that actually very convenient, very close to us. Okay, so I can give you an example like our mobile phone. Mobile phone has become a part of the humanization of technology, meaning that you carry the device every day, you use the device for productivity, okay, for messaging, okay, to communicate. So it becomes part of the humanization of the technology. So mobile phone ecosystem has been very well accepted. Okay, so this is what IoT is looking into as well. So when you look at the application, there are many to choose from. Okay, so and then the listed, okay, here is like automotive, healthcare, okay, home automation, industrial, utilities, smart grid, and smart city. Okay, right. So although these are the categories, but it is very important to understand that this category, normally the success of these categorical applications depends on the social context, right? Meaning that, okay, like in Malaysia or in Southeast Asia, probably home automation might not be a good use case, but smart city, yes. Okay, because whenever you develop a project or an application, we have to look at the social context and cultural setting. That's how the technology could blend in, not just picking up a use case from US, for example. Okay, you take a white paper from US and then you want to apply in Malaysia, it doesn't work. Okay, because mostly technology has to be blended with the cultural setting. Okay, then we can ensure the success. So in Malaysia, automotive might be relevant, okay, because we have a car producers. Healthcare, yes, okay. Home automation might not be, okay, might be 50-50. Industrial, yes. Utilities, yes, and even smart city would be the best. Looking at the popular size of population in Malaysia and our country's diaspora. Okay, so that's how we see. So today we have a lot of enablers, right? Significant technology that can help us to come with an IoT solution. So we know that sensors today are very cheap. Okay, you can even get for RM2. Okay, from Shopee or Lazada. Okay, if you want to buy a simple ultrasonic sensor, okay, photo sensor, okay, the price is tremendously very cheap. Then the cheap bandwidth, okay, we don't have a data issues anymore, so the cost of bandwidth also decline. And cheap processing, okay, nearly 60 times over the past 10 years. Okay, so that is quite easy to process the data. Then smartphones become a personal gateway. Like most of the consumers today, they have a smartphone as their digital identity. Okay, so we can use our smartphone to access those dashboard or data. and you have ubiquitous wireless coverage. Like in campus, we have like Wi-Fi hotspot. So it's not may not be an issue for us to access this. The big data, okay, the way IoT will generate voluminous of data, okay. So that's also an important consideration, because we are talking about large volume of sensors. So this large volume of sensors will generate voluminous amounts of unstructured data. So here we have to consider about the way of processing big data. So when you talk about big data, then there comes the importance of machine learning. Okay, so machine learning will actually help us to reduce the processing load, okay, and give you more accurate information, right? Then we have the IPv6. Okay, IPv6 is actually Internet Protocol version 6. Okay, it's actually protocol that actually to support more devices. But today, even though IPv6 is there, we are still some of our existing legacy devices still use IP version 4. So IPv6 was introduced to accommodate IPv4 because the networking manufacturers thought that, okay, one day kita akan kehabisan IP. We will be, shortage of IP address. But it doesn't happen like that. Okay, it was just a prediction, but it didn't happen. Okay, but still, today when you buy a new laptop, new mobile phone, all of them they support IPv6. So with Internet and Internet of Things, IoT, the most important thing that is that we are talking about heterogeneous interconnected objects. Okay, heterogeneous means that various, okay, diversified devices. Okay, pelbagai, meaning that you have a CCTV that can have a data on video. Maybe you can have a temperature, data temperature, a static data. So we have a diversified kind of objects that will collect those data in rapid and real time. Okay, so the real philosophy of IoT is not on how we connect, but what kind of services that we can offer. Okay, yang tu yang penting, meaning that what type of the services that you can actually offer with IoT. So like the vision of IoT is that one day, okay, when let's say you misplaced your mobile phone, okay, so when something, or maybe any object that you misplaced, okay, you left somewhere, maybe one day you can just open the Google search engine, then just type where is a mobile phone, it will tell you exactly where the mobile phone is. So this is the vision, meaning that at one stage, we will be able to connect all the objects simultaneously. Okay, it might sound dangerous, okay, but that's another issue to discuss. Okay, because nobody wants to have connect all those personalized devices on the internet. Okay, there might be some security issues, okay, privacy. Okay, so we have to look into all this. Okay, but these are, I'm just telling you the vision shared by the IoT community. So a lot of challenges is there, okay, in terms of technical, okay, what kind of a device I need to buy, what kind of programming I need to learn, and language, okay, programming language, and how do I manage the data, how would be the software platform challenge, okay, that's on the technical side. Then on the business side, okay, if you look at industry, they will look into the revenue, value chain, business model. On the society, okay, we will care about the privacy, ownership challenge, right? Easy to use and social cooperation. Okay, so if you look at all these challenges, technical and business is not the major ones actually. The major challenge is actually societal challenge. Okay, it's always important to secure the privacy and ownership. Okay, because consumers, okay, public will only trust a device when it is safe to use. Okay, so just like when we accept the mobile phone, that's how we should accept the IoT. So that's how everybody's working on that. So if you look at the analogy, right, from the first to fourth industrial revolution, IoT actually comes under the fourth industrial revolution. So we have come far away from industrial revolution 1, okay, then 2.0 and 3.0 when we have this IT, further progression in autonomous production, and today the level of complexity increases, but we call this actually a cyber physical systems. So sometimes when you look at the textbook or even some notes tutorial from the internet, you'll notice that the IoT is normally mixed. They have a mixed terminologies with cyber physical systems. In UK, it's very common they use the word cyber physical systems, especially in Europe. In US and Japan, they like to use Internet of Things. Okay, both of them are similar, but it's just the conceptual how they see autonomous objects, right? In terms of IR 4.0. So the industry is hyping, okay, telling that we're going to have billions of devices. So what is the application? Why would a consumer want the device? Okay, that's the first question. And how does it get connected to the world? Where is the intelligence? And can consumer trust the devices? Okay, these are the 4 questions that we call it the essential elements that we need to ask before we get ourselves involved with the development of IoT. So a simple example, okay, you are seeing now is a racket. Okay, so this racket, I think normally kita guna ni untuk guna play badminton, right? Or maybe tennis, right? So you're seeing a traditional racket which is used in the sports, and the other side you see a connected IoT racket. So what is the difference is that the traditional racket is purely for games, right? To play the match. But when you want to transform the traditional racket to an IoT enabled racket, you will notice that there are some additional components that we need to add on. Okay, for example, battery. Okay, you need to have like accelerometer sensors, gyroscope, magnetometer sensors, right? And then you have this sweat sensors, for example. You have SD card slot, okay, storage. Okay, so you see that when you transform a traditional object to an IoT enable, we really have to see what is the objective. Okay, does it really essential for us to turn the traditional racket into an IoT object? Because today we can just transform any traditional object into an IoT object. But before we transform, we need to see the objective, the problem statement. Why would you want to transform the traditional object into an IoT enable? What is the purpose? So in this case, in this game, okay, probably in the badminton, when you have an IoT enabled racket, probably you can measure the player's health status or vital sign. Okay, or maybe this data can be used to plan for the game strategy, for example. Okay, so you can have some additional data that can be helpful for the game strategy, right? So this is very important to know before we embark on any IoT project. We must be clear what is the actual problem and how do you want to use IoT in a particular domain, right? So on the higher level, right, there are many research going on, okay, especially on using Internet of Things as a brain-to-brain interface, okay, using brain signal to serve the internet, using the brain signal to control something, to control a device, okay. So you also use you can send the signals to other person's brain. It might be useful for disabled citizens, okay, to communicate with others. So these are some of the advanced level of IoT researchers that also include some medical expertise to collaborate together, right? So wearable device, I think we are quite familiar with this wearable device. Okay, mostly I think wearable device in the market today is about fitness tracking. Okay, so like we want to go for jogging, we wear a smartwatch, a wearable watch, then it start to calculate our steps, okay, the calorie burn, the time, okay, heart rate, pulse rate, okay, some of the health data, right? Fitness trackers, it's quite popular, right? So at the moment, if you look at the trend, most of the wearable devices are very much focused on healthcare domain. Okay, but actually wearable device, it can be very useful in IoT domain. Okay, it's just that no innovations is being carried out yet. Okay, I can give you an example. If you go to Kedah, okay, the state Kedah, I think we call this a Negeri Jelapang Padi. right? There are a lot of paddy fields, right? Even the nearest would be Skrinchen in Selangor. Okay, if you see that in paddy field, normally farmers are working, all right, to monitor their paddy yield, right? What will happen is that we can actually use a wearable shoe, for example. Okay, wearable shoe, and this wearable shoe can be embedded with some sensors that can collect the data about the soil or the moisture of the soil. Okay, rather than fixing a device or system on the farm, on the field, you can just plug the sensors within the shoe, and when the farmer is working in the field, all right, subsequently real-time data is being collected, right? So by doing that, we can know the moisture data, okay, the soil content, materials, right? So some of the specific data that can be done if we have some innovations on this kind of wearable device, right? So wearable device do not limit to smart watches, okay? It can be a shoe, it can be a clothing, textiles, or it can be anything that we wear on our body, right? So that's wearable. So if you look at the recent IoT products, right, there are a lot of these products, okay? For example, the thermostat, wireless cardiac monitor, remote, okay, tractive pad tracker, okay, Ninja blocks, okay, Revolve, home automation, okay. And if I tell you that these products are not invented by tech companies, okay, they are designed by fresh graduates who just finished their final year before they go to their job placement. So they actually came up with this kind of IoT products. And these products later on was actually bought over by the tech giants. For example, the first one, the Nest thermostat, it was designed by 3 students, right? And then Google actually bought over that product. So the fresh idea comes from the students in universities, especially when they want to design IoT products, right? So these are a few examples. Okay, so for any beginner, okay, for those who want to learn IoT, okay, maybe if you want to learn, if you want to apply IoT in education, okay, the first thing is that to understand the 5 key components, right? This is very beneficial for any beginners who wants to know about IoT more. So they have to look into these 5 key components. The first is power and storage management, security and privacy, microcontrollers, sensors and actuators, and connectivity. So we'll see one by one. So like power and storage management, okay. So Cisco Systems, okay, it's actually a networking company. They predicted there will be 50 billion IoT devices by 2020. Okay, now we're already 2021. But today we don't have 50 billion devices yet, right? So maybe people can question, maybe because of the pandemic, we don't have IoT devices. It's not like that. It's just like the acceptance of the IoT devices is rather slow than compared to other domains. Okay, probably because it's a new field, and we see that the IoT is much relevant in other domains rather than computing itself. What I'm trying to say is that the Internet of Things should be supporting other domains like agriculture, education, even forestry, rather than just focusing on computing. And that's how it works.
Dr. Tina, maksudnya IoT ni is actually a problem solver untuk the problem that we are facing about domain sekarang ni kan. Kita
Betul.
nak capai big data, AI dan sebagainya, kita masuklah domain kan. We never have this cross domain. So sebenarnya IoT is actually yang sepatutnya menjadi apa tu? Enabler lah. Enabler untuk domain ni kan.
Betul. Jadi dia lebih kepada enabler.
As soon as people understand about how we could reach AI dan sebagainya nanti, big data semua, IoT ni is a crucial part of the technologies kan yang akan differentiate domain atau to merge everything into one domain dan sebagainya kan, betul?
Betul. Dia akan jadi dalam top layer, nanti dia akan tarik semua domain masuk dalam.
Okay, faham.
So 50 billion IoT devices, we are not there yet, okay. But It's just like a prediction made by Cisco. Okay, but one thing, okay, we know that IoT they consume a very less power. Okay, like for example, if you're charging your mobile phone, I think you just need 5 volt, okay, 5 volt. So same goes to IoT, and then maybe it's 5 volt and then few milliwatt. Okay, but it still takes up a lot of power. That means that there'll be a staggering demand of power because we are talking about thousands of sensors or 2,000 of sensors. Okay, so when you talk about volumes of sensors, that means there'll be staggering demand for power. So one of the research, okay, done by the engineering groups, okay, they'll be looking into this ultra low power designs, energy harvesting, even solar, okay. Like in Malaysia, we are very fortunate because kita dah panas dan lembap sepanjang tahun. Okay, and our climate is very unique. We get sunlight almost throughout the year. So if we can, like capitalize the solar, I think that would be the next economic growth for Malaysia, right? Rather than just focus on hydroelectric. Okay, if we can really capitalize on solar, because solar is clean and it's renewable, that would be tremendously another economic boost. Okay, but it depends on the policymaker, of course. Okay, how they are going to see this. So another issue is that storage. Storage management is like most of the data from the IoT device, we will push them into a cloud. Okay, cloud is actually we call as a cloud computing. It's like a server that the server is reside in somewhere else. It can be segregated in different location, and just like today we are using our Google Drive, okay, Dropbox, okay, the same methodology. I mean, you can push your IoT data into remote cloud, and then the moment the data scale up, you can actually retrieve, again, and so on. But the issue is that when in the next 5 years, we will see that more and more personalized IoT device. Okay, for example, like fitness tracker. Okay, like fitness tracker is like your personal data. Okay, you don't want anyone to know about your health status, health data, right? Because that's a very sensitive data. Okay, so you want to store that locally. You don't want to put that in a public cloud. So we can actually think about how to store those data locally, right? Just like like in education, you have like MOOC, I think massive open online courses, right? So yeah, you have like you can push it in a different location of the part of the world, okay, using a cloud technology. But probably there are some copyrighted materials that you want to have access within the local vicinity, then we can think about that. Okay, that's how an IoT can help to realize that. So the next component, okay, we have to consider is about security and privacy. Okay, security and privacy is a never-ending issue. Okay, no matter how advanced is our technology in IoT, okay, how advanced is your machine learning algorithm, definitely there'll be somebody wants to break the system, want to breach the data, and so on. Okay, it's a never-ending problem statement actually in computer science, because there'll be a rapid transformation in consumer-centric information, and we know that when you talk about IoT, it characterizes data-intensive environment. Okay, there'll be a lot of data around us. So sometimes this data can be personalized, sometimes can be vital, right? So we have to make sure that there'll be an effective data protection to prevent the confidential information falling into wrong hands. So user, right, consumer like us will only accept when we are safe with the security and privacy issue. Okay, so at the moment there is no clear guideline about this security and privacy. Okay, and that's the reason why we see that the growth of IoT devices for public is rather slow. Okay, but in terms of enterprise, organization, okay, yes, there is a lot of IoT implementation, but we don't see IoT as end product yet, not much in the market. Okay, the third component that we need to know is microcontrollers, okay, MCU. So the general perception is that, okay, people think that, okay, microcontroller is from engineering, it's very difficult to learn. It's not like that, because today we are talking about open source hardware. Okay, open source hardware is for everyone. Okay, and if you're familiar with the makers community, if you're familiar with the hobbyist kit, okay, anyone can just buy an Arduino, okay, or Raspberry Pi board, and then can get started with this simple IoT applications, right? So microcontroller, they are very important because they can bring the needed intelligence to the devices, and they can deliver meaningful predictive analytics and data reductions. So today, if you look, there are a plethora of choices. Okay, like if you go to Lazada or Shopee, you can just get an Arduino Uno board. Okay, I think which is cost you around 50 to 60 ringgit. Okay, BeagleBone, Intel Galileo, Raspberry Pi. Okay, also like a good choice to get started for IoT. So for a beginner, I would really suggest to go for Arduino. Like in UPM, our curriculum, for the bachelor students, we still use Arduino and Raspberry Pi for their laboratory and for their theoretical classes. Okay, especially in the subject Internet of Things, right? So this is how when the students get started, they have the Arduino board. Okay, they have other components like LCD display. They come up with the simple applications, programming using a C, okay, or Python, right, language. And in today, if you look at our Malaysian schools, right, especially in the STEM education, okay, there's been a lot of workshops, programs carried out, especially using Arduino and Raspberry Pi, okay, especially in the STEM. And there are some bespoke IoT boards, meaning that these are more advanced level boards. And if somebody is doing research on IoT, they might be keen to use advanced board. The difference is that this advanced board, they have much better performance. Normally, they are used for test the algorithms. Okay, some of the machine learning algorithms can be tested using this IoT board, advanced IoT boards. The fourth is actually the sensors and actuators. Okay, choosing the right sensors is important because you want to detect, gather, and measure data based on inputs and then act upon the data. Okay, so for example, okay, if you want to do a location-based services, all right? Okay, for example, I can let you know. I can give an example like yeah, I think everybody familiar with IKEA, the furniture company. Okay, I think IKEA. I think you have to look at the catalog and then try to locate their items, right, in their rack. Okay, then you pick it up and then you bring it to the over the counter and then that's it. Okay, but what's happening now? IKEA is trying to use IoT. Okay, what they're doing is that they will have a beacon that is actually attached to the material. And all we need to do is just take up our mobile phone, turn on the Bluetooth, and scan for the beacon based on the given code. So by doing this, it's easy for you when when you want to locate the items. Just carry the mobile phone, and the mobile phone will direct you to the right rack, right? So this is being done in the overseas, but in Malaysia, I'm not sure they have implemented yet, but they are trying to do that. They're using the location-based services, indoor positioning services, using those sensors. Okay, so choosing the right sensors are important because if you know well your problem statement, your applications, you need to know the correct sensors to be selected. Okay, for example, if you're working in smart city, we know that the issue is traffic, parking, okay, garbage collection. So what are the sensors related to this domain? So that's how we have to narrow down. Okay. So these are some of the example of sensors. Okay, machine vision, acceleration. Okay, force sensors, flow sensors, and so on. Right. So it's a very huge, I would say, a huge subtopic. Sensors, to learn about sensors is not one day because we explore by applications. The moment we get involved in project, then we learn about new sensors from time to time. Okay. So these are some of the sensors available in the market, and this is good for the beginners. Okay, so Just get a couple of sensors and an Arduino board, you can get try in simple applications. Then the fifth component is actually connectivity. We know that IoT crosses a broad range of data rates. Okay, as I mentioned just now, we have hotspots everywhere, so everybody is very comfortable using Wi-Fi, okay, as a means of data transfer. And this kind of Wi-Fi is actually that can leverage on many communication technologies with always-on experience. Okay, but there's another protocol that is coming up, which is called Bluetooth, right? Although Bluetooth is not a new protocol, it's been there. Okay, maybe I think when we before the era of smartphone itself, we have this Bluetooth protocol in our mobile phone. But today, Bluetooth, they have improvised the protocol. They become a low power. They call it Bluetooth low energy. They are much better than Wi-Fi actually. And many of today's IoT projects are using Bluetooth. Okay, I think there are some projects like Future Classroom. Okay, they will be using Bluetooth for their attendance system. So this is the difference between Wi-Fi and Bluetooth. So when we want to get started with this projects, I think these 5 components really matters. Okay, so for a beginner, if you have to know about the power and storage, security and privacy, okay, microcontrollers, sensors and actuators, and finally the connectivity. Okay, so these fundamental 5 things are key for any beginners to get started with an IoT project. So IoT and smart homes, okay, I think whenever we read online resources, okay, even textbooks, okay, the first thing that IoT, they always try to relate with smart homes. But as I mentioned, maybe the use case of smart home might not be suitable for us in Malaysia. Okay, or even if you look at our Southeast Asia, maybe in Singapore, yes, because Singapore, they have a high-rise building. I think mostly rumah pangsa, condominium, right, apartment. But mainly in Malaysia, our cultural setting, socio-economic context, okay, might not be good use cases to pursue. Okay, but smart city, yes, right? But to get started with the project, IoT and smart home is a good analogy, because you see that there are a lot of sensors in home, like like lighting, camera, thermostat, smoke alarm, okay, speakers, irrigation system. All these can be connected and they can start collecting the data themselves, right? So that could be a good start for a project. So when you have the IoT, but the biggest challenge is how you want to push the data. Okay, the data itself, because your finally the data matters. Okay, you have the good hardware, you have the sophisticated hardware, you have a nicely built sensors configured. It's collecting the data, but how do you push the data? So this is where we need this cloud technology. Okay, so the cloud technology is like we collect the data from the camera, we collect the data from the temperature sensor, then we have to aggregate them in the cloud, and as a consumer, we can able to see the model, the predictive models. We can analyze the data within the cloud itself, okay, using a dashboard. So this is another component, but it's always coexist with IoT. Okay, the IoT and cloud computing, they coexist. You cannot separate them. But today, we don't focus much on the development of cloud because the cloud technology is very mature and it's already there. Our focus should be on the use case, on the algorithms, all right, on how it can solve a problem. So this is an example. Okay, if you see that there are sensors, and these sensors are configured through a microcontroller unit, right, Raspberry Pi. Then the data is generated, okay, from the home. Okay, for example, if there is a fire alert or any source of data, okay, any source of data that correspond to home, those data can be pushed into the cloud databases, and then within the cloud we can use some machine learning, okay, even AI like rule-based system to classify, okay, to analyze, and then finally transform them into a dashboard, okay, visualize them. Okay, so this is the loop, okay, from the sensors to the microcontroller to the cloud, and then finally to the dashboard. Okay, so this is the complete cycle of an IoT project. All right. So if you ask what would be the important component, I would say all of them are very important because you need the hard sensors, you need the microcontroller, you need the cloud, and finally the dashboard. So there are 4 major components here that you can't separate them. It has to be interlinked, right? They have to interoperate each other. So programming language, okay. What kind of programming language? Okay, if you see in the computer science, normally the students are exposed the first year itself. Okay, they learn C++, okay, C#. I think even in the schools, I think Python is already there, okay, to learn, right? Java is always part of the curriculum, Node.js. So there are a lot of choices for us to learn, and there is no restrictions of a particular programming language is for IoT, okay, meaning that you can use any language. Okay, so normally the selection of the language is depends on the hardware spec. Okay, if you look at Arduino, you have to know about C. If you look at Raspberry Pi, another form of microcontroller, then Python would be helpful, right? So Arduino is very common, right? Common platform. I think maybe in future, if permitted, I can give a talk on even a small workshop on Arduino if needed. Okay, for those students are interested. Okay, that would be handy. All right, it's very common. It's an open source tool. Okay, open source hardware that we can easily learn. So apart from that, okay, there are many cloud platforms that we can use, like Microsoft Azure, Amazon Web Services, okay, Google Cloud, ThinkSpeak, Samsung. If you see these are all giant companies, all right? All the tech giants, they don't focus on hardware. They just want to focus on the cloud because data is very expensive. The revenue is actually from the data. And that's why you see that most of these tech companies, when they want to venture into IoT, they focus on the cloud platform. Okay? So we can also create our own cloud. No harm. Okay, that would be better. We can create our own server. We can have our own cloud. We can manage the data privacy, data security ourselves. Okay, that would be good, right? If you're looking into large scale. So this is an example of how the Amazon AWS, Amazon Web Services Cloud platform works. So most of the cloud platform, they will give you the algorithms, right? The rules engine. They will give you the application API. API means application programming interfaces. Okay, if I want to develop a nice dashboard, I can just use the API. Okay, I can just drag and drop. I can have a nice API on that. So it's like one-stop center. So same goes to Samsung and IBM. They're quite similar, right? They give you everything. It's just that we need to configure based on our application domain, and then we start to see the data collected, right, from the dashboard. So this is how, when you have the list series of microcontrollers, they can be connected to the cloud, okay, the field, and then they can be, visualized in the dashboard. So dashboard is important because, this is where you can see how many devices you have, what are the access you have, okay, how do you log the data, like, you want to create some rules and action, okay, say that, let's say, maybe Encik Mazlan have a CCTV at home, right? So you want the CCTV to capture every minute and then push to the cloud. That would be expensive because, image file is bigger, right? So maybe you say that, okay, I want the CCTV to capture every half an hour. So 24 hours, you have a 12 image, for example, okay? Maybe, 48 images. So that's how it's like we create a rules and action for that. Okay, like temperature sensor. We cannot collect temperature every second or every minute. Then the storage will become big. So we have a cycle. We say that, okay, we'll set in the dashboard, we say that collect temperature every 2 hours. So, and then you collect the temperature 9 to 5, and then you plot the graph. What is the temperature from 9 to 5 p.m. So this is what we call creating rules and actions. This one we can do through the dashboard. And finally, we want to visually present the data, right? So when we want to develop an IoT project or product, the dashboard really matters, because that's the outcome that users actually will see. So this is actually infographic. Okay, I just purposely put it here because it talks about some of the problem statement that we can explore. Okay, some of the domains, like in structural health, that is civil engineering, sportsman care, that will be in the sports, offspring care, that's in child care, okay, forest fire detection, air pollution, smart parking, waste management, traffic congestion. You see that most of these IoT applications are out of the domain. So Libelium is actually a IoT company that produces hardware. Okay, and they normally don't produce for end users, they produce hardware for enterprises, okay, organizations who wants to come up with an IoT project. So we have seen about IoT, okay, and we want to also see how IoT can push to digital transformation. So with the use of technology to radically improve the performance or reach of enterprises is what we call as digital transformation. So digital transformation is not a new topic. It's been spoken long ago, and then there have been many policies, paperworks, okay, the way enterprise, even in Malaysia, okay, or in Southeast Asia, has been going through. Okay, so what we want to see is that how IoT is actually accelerating the digital transformation in all areas, right? So like industry leaders, okay, the populations, the organizations or the companies, they are thinking that with IoT, the digital transformation will happen quickly. Okay, with IoT, the digital transformation will happen quickly. So how this is possible? So like IoT will be part of the several initiatives, like asset management, our user experience, product and service experience. So it actually is trying to bridge from the traditional values to the digital experience. So if you see that after the pandemic, I think we have seen that a lot of technology, okay, has been tried to reshape the business conduct and consumer behavior. Okay, I think we often hear now that about the less contact society. Whatever we want to do, we want to have less contact, some social distancing. Okay, so this of course this technology exists before the pandemic, but looks like after the pandemic this technology become more relevant. More relevant meaning that we see that like for example the COVID pandemic has accelerated 10 key IoT based technology trends. So if you look at some example like online shopping, okay, I think today it become very common, right? Online shopping. And then although today we have in-person delivery, but maybe in future we don't have a person to deliver. We might have like autonomous vehicle or autonomous drones who actually does the delivery, right? Post Malaysia is doing a project, a pilot project. Okay, Post Malaysia. Okay, I think we know about Post Laju, right? Post Laju, Post Malaysia is like try to see how to use the drone to deliver the items or parcels in one location. Okay, and also Asia, also they have they are doing some pilot testing. Okay, trying to do some food deliveries using drones. Okay, and of course this food delivery, online delivery, they are being supported by IoT technology. Because how do I say they are supported by IoT technologies? Those data, those delivery data, item data will be used using IoT devices to push the data into the cloud and in real time, right? We need something that real time. Okay, contactless payment, I think yes, digital payment has been there. Okay, that enable people to make online purchases, payments and goods and services, right? Okay, then we like many organizations today is asking employees to work from home, right? So we have a lot of technology already, like virtual private networks, voice over IP, virtual meetings, okay? But using IoT, there will be more important collaboration tools that you can actually quickly get things done, actually. The issue is that we are not using the technology fully. I mean, we are not using the technology as it should be, right? So that's the reason why we don't see much collaboration tools, right? But of course, in coming years, we will see that more and collaboration tools that actually can use IoT to increase the productivity, okay, or less hassle, for example. So distance learning, right? I think many educational institutions already started to offer online courses to ensure the education was not disrupted, okay, by the lockdown measures or so on. So to support that, okay, there are some IoT enable, okay, technologies that can actually co-hosted together with virtual reality, augmented reality, okay, 3D printing, or even artificial intelligence enabled robot teachers. Okay, this is can be some good use cases for IoT for education, right? Okay, so all this has been highlighted in the IR 4.0 roadmap. Okay, but the thing is that when it comes to educations, right, it has to be very holistic way. We should not like randomly, pick up a technology and then try to test it. It has to be holistic way, meaning that it has to be taken into account of every stakeholders. So that's the difficult part actually. It's more on the policy side. Okay, but definitely technologies will help, especially IoT. So on the telehealth, okay, we see that like wearable personal IoT devices can track vital signs, right? Telehealth can be like medical services, rather than visiting doctors, sometimes you can have those devices collect the vital signs and they can send the data to the medical practitioners and tell you what's going on and so on. Okay, but again, this is optional. Okay, online entertainment, I think the moment theaters, cineplex has been closed down, we saw that a lot of movies are being released online. We call this over the top platforms, right? So like Netflix and so on. Okay, 3D printing, okay, has been deployed to mitigate shorts, supply chain and export bans, okay, on PPE. So today by having 3D printing with IoT, you can just download any design that you want and then can 3D print immediately what you want. Okay, so we are actually cutting down the supply chain demand, right? Because when you have a 3D printer, you have an IoT, then you can just download the design and then you do it, print it for yourself. Okay, robotics and drones, okay, like mentioned previously, okay, they are putting some rollout, okay, some like in China, robots have been used to disinfect areas and deliver food to those in quarantine. Okay, so this is just part of it, right? So there are many possibilities, right? What we can do with IoT. Of course, a very clear use case would be, transforming the environment around us. Okay, for example, like buildings, right? Campuses. We can actually use IoT sensors, and then start collecting data like energy usage patterns, temperature trends, and people movement throughout the building, right? So one thing is that I think during the PKP, okay, last year and this year, many organizations, right, institutions have saved a lot in terms of energy usage. Okay, energy usage. So, because most of us are working from home, like that actually has saved a lot of, I think, millions, right, of the revenue, government revenue, okay, on energy usage patterns. So this kind of data can be used to model, okay, to see how we can capitalize, okay, on the savings, especially on the energy usage patterns. So we can use IoT sensors to improve future building projects, okay, and how to manage the building in a coordinated way. Okay, like this is an example of IoT project. Okay, what you see is a safety helmet. Okay, normally safety helmet we use in construction site, okay, or some of the critical field works, right? So by using IoT and augmented reality, we can actually overlay the job, real view of the job to be done or the journey to be traveled, right? So this is one example how you can use it IoT for operational instructions like navigation or driving information, right? So that can be one example. Okay, this is one that's being implemented in Australia. Okay, then you have this building information modeling, just like I showed you just now, when you have these models that can be in turn updated by the IoT sensors placed in the buildings that have been constructed. And these sensors can send back information, by affected by changing climates and the passage of time. So we know how the building is actually affected by the climate changes and so on. Okay, so like for example, if you want to repaint a building, some data can be given by IoT sensors to show you that, okay, the paint is become rusted, for example. So that could be save our cost and it can help our planning for building restoration. So like workers, okay, they can also use wearable with IoT to monitor their health and alertness. Okay, for example, those who are working, long hours, they can be tired, and there could be some possible accidents. So this kind of alert system using IoT and wearable can be really beneficial. It can, it can tell us what action can be taken if the limits are in danger of being exceeded. So this is one example of IoT and wearable in constructions. Okay. Okay, in education, okay, like University of New South Wales, okay, they try to use IoT to make facilities management more efficient. So what they've done is that they by placing the sensors on trash bins to indicate the field level and using the video surveillance to identify common areas that need cleaning, the network can ensure facility maintenance resources are deployed. So it's more like monitoring their facility management. So the university wants to make the campus clean. So they try to see the volume of the trash bins, okay, by monitoring it using IoT. Okay, so like so that they can manage the facility maintenance accordingly. They can schedule and so on. Right? Okay, transport. Okay, I think some of the airports, international airports, okay, they are using IoT to connect their retail management system for mapping, okay, for shopping experience, airport dining. So they even check the number of occupancies in the airport at one time. So they use occupancy sensors with the help of IoT technology to see how many passengers or how many people are moving within the airport vicinity. So this kind of technology, I think after this might be relevant. I think if you want to control the crowd or you want to see the number of crowd in one location, okay, maybe I think this could be a good use case for pandemic issues, okay, can be part of the SOPs and so on. Okay, supply chain management, right? Also in manufacturing, okay, where you see that logistic, okay, they can use RFID tags with the help of IoT to track the number of devices, okay, sorry, the number of items, okay, goods, okay, that can be very beneficial. For utility, okay, you are like power plant, okay, factories, they can use IoT to check the consumptions, okay. Just like TNB, I think with TNB today, we can see, you can log into the portal and see our house electricity consumption because we are of the smart meter. So the similar example, you can use it in other utilities as well, like water and so on. Okay, so these are some of the very common example on how IoT drives digital transformation. Okay, so you've seen that. Okay, yeah. So three fundamental operations. Okay, like what we see that with IoT, we need to collect the data, we need to process the data. Of course, when process the data, you need machine learning or any semantic reasoning or even base processing, and then finally to control the data, right? So the collection is fine, even the control is fine, but processing the data is the challenge. So some skills are required, especially to learn how to process the data. And this is what been emphasized in IR 4.0 roadmap. So of course, okay, even we have the skill, it's not that simple because we know there are heterogeneity. All those IoT sensors belongs to different domains. and how these sensors, they use various technologies. Some may use Wi-Fi, some may use Bluetooth. Same goes to actuator. Okay, they have different protocols. Then how do we manage the connected objects? So they are conscious to the high mobility, naming and addressing the billions of objects. Okay, the discovery of the objects is another issue. Processing, okay, utilizing semantic web technologies, standardization efforts. Okay, so I can give you an example. Okay, Jambatan Pulau Pinang, right? It's 13.5 kilometer, right? So if you remember, during December 2004, I think there was an earthquake in Aceh. 2004, I think there was an earthquake, and there was also tsunami in Aceh, Indonesia. So what happened is that at that point of time, we felt the tremor in the Penang Bridge. Okay, so what happened is that UPM, with the instruction of the Kementerian Tenaga at that point of time, we did a sensor installation in the Penang Bridge. Right, sensor installation. What we do, we install the accelerometer and inclinometer with the wireless gateway. Right, so the bridge was 13.5 kilometer. We tried to divide the 13.5 kilometer into 4 zones, and there were a lot of issues because that is back in 2011. Because when you want to use Wi-Fi in a bridge, you need a lot of gateways, Wi-Fi gateways, and the condition of the bridge itself. Okay, because you are surrounded by seawater. So when you install sensors, the high possibility the sensor become rust, karat. So you need a nice enclosure. Okay, the placement of the sensor, and to pull a power battery to charge the battery. It's not ideal to charge the battery every time, every 1 or every 3 months, because you have to go down to the bridge and then take a boat and then check the systems one by one manually, which is not feasible. So we suggested to use solar panel, and by using the solar panel, the batteries are charged throughout the year. Okay, so this one example. Okay, managing IoT objects are not easy because there are other issues, the external factors that we have to see, especially tailored to their respective environment, right? So sometimes standards can help us. Standards means that standard documents, right? Because they promote open data and interoperability, they can help us to promote consumer-centric solutions. So of course, there are a lot of standards available today. Okay, like in Malaysia, our standards are being taken care by SIRE, right? And also Jabatan Standard Malaysia. So they are working together. Okay, and most of the IoT standards in Malaysia are actually a mirror standard from overseas. Mirror standards meaning that we actually borrow and then we try to suit with the local requirement. Okay. So so to achieve the IoT ecosystems, right? We know the objects need to be connected to the software. Things need to be made available to use together the system. So the IoT architecture and protocol is already there. They can address the first item, but the second item is the big challenge. How I want to glue them together. To glue them together is the biggest challenge, because you have a legacy system, you have a new system. Legacy system might use different protocol. New system might use different protocol. So I need to glue them. Right? So sometimes standards can help. Okay, especially when you talk about IoT in big use cases like smart grid, utility. Okay, there are already a clear guideline how we can use it. Okay, like healthcare. Okay, there are a lot of standards in healthcare. Okay, if you want to use IoT for transceiver, pill camera, there are many standards that we can use it, right? Also in transportation, like today, I think we have MRT. MRT, they're actually using real-time operating system, but with the help of IoT actually. Okay, it just we don't see that in the front end, but it's actually working in the back end. There are some real-time data being collected by MRT, especially the number of passengers, okay, the schedules and so on. So standards can help, especially if we are working in IoT projects in a bigger scale. But for a smaller scale, I don't think so that you need to refer the standard document. So like the implications of IoT. Okay, we know that leading edge companies will use IoT to gain competitive advantages, right? So this could result in new application and services from time to time. And of course, you know, when, as I told you previously, when we deal with the sensors of IoT, large volume of data, we have to deal with the large volume data. So that definitely we need a new law on privacy. Okay, because we cannot misuse the data, or cannot let other people to misuse the data, right? So normally when we talk about the problem statement in IoT, we see use cases on smart homes, smart cities, waste monitoring, you know, smart watches for fitness monitoring. Okay, this is very much urban centric, but I think this is the right time. We have to think out of the box. We have to start looking into the use cases that can actually solve the real social problems. Okay, social context. For example, I think in Selangor we have a water issue. Okay, normally we have this pollution at Sungai Seminyi, right? It's quite common. So probably we need to come up with like a use case to use IoT for better water management, or maybe a landslide prevention. Okay, in Pahang, for example, river water quality improvement, for example. So out of the box use cases would be really something to look for in the meantime. So we have seen that drivers, okay, like the low cost, smaller, smarter sensors can be embedded in anything. Then the internet actually helps us, you know, to come up with these explosions of mobile devices. And today we have the challenges on how we want to deal with the new data. At the same time, we want to ensure the security, make sure the application that we develop follows the culture, skills, and the business process. And at the same time, it also leverage on the legacy systems, okay, because of the investment. So some common mistakes, okay, like when we develop an IoT project, we don't want to add functionality that user don't want to pay or don't want to use it, okay? So we must have a clear value proposition for the consumer, and never underestimate the security and privacy risk. So I think if you remember the Google Glass, once upon a time it was very popular, but somehow after that it slowly died down, okay, because it didn't fail because of the technology, but it wasn't clear to the consumer what problem they solve and why they need it. So people thought that, you know, browsing the internet using the Google Plus something a cool idea, but it's actually not. It's more eye strainful. It becomes strainful for your eyes, right? So that's why we need to have a clear use case and clear problem statement. So so there's some predictions, right? How use organization will tell us how IoT will be standardized and how consumers will be attracted to application. They'll buy things and they'll keep the device they can trust. Okay, so these are just predictions, but again, coming back, it's always important to see the problem statement and how we can use IoT to bridge the inter-domain linkage. So that should be our focus actually. So okay, this a complete IoT use case I can share here, right? If you look at this diagram, let's say normally when we have a home, okay, and there is an elderly patient at home, okay, maybe our grandma or grandfather who is actually, you know, bedridden, or maybe not having a mobility, couldn't walk around. So we want to install a sensors, okay, and we provide them a wearable, for example. So in typical cases, when something happens, when they fall down, the wearable will alert the ambulance or the nearest hospital, right? That's the typical cases. But when we use IoT, there are more things to be considered. Okay, so let's say when the elderly patient falls down, it immediately won't trigger the ambulance or the medical center or the hospital. What we will do, it will actually contact the local council, Majlis Perbandaran, okay, and then it will actually contact the nearest police station, Balai Police, okay, and it will also contact the Cawangan Traffic, okay, and then finally it will send the data to the hospital. The reason is that because we want to have a real-time synchronization. The moment the ambulance comes from the hospital, reaches the home, and picking up the patients and going back the same route without any traffic or hurdles. So a lot of real-time data and a lot of real-time stakeholders involved in this kind of setting. And if you want to coordinate with the home, the patient, the Majlis Perbandaran, the hospital, okay, Balai Polis and Cawangan Traffic Tempatan, it has to be coordinated with proper algorithm and proper scheduling policies with the help of IoT. Okay, so we can implement this in Malaysia, and this will work because of the infrastructure that we have. Okay, so this is one of the projects that we carry out in faculty computer science. Okay, and some of the work that we are doing here in UPM is like an IoT-based activity recognition. Okay, this is like more like this is a very raw prototype. Okay, it's like a glove for visual impairment. Okay, normally I think when you see blind people, they walk with a stick, right, to detect the object in front of them. So by using this glove, the glove will actually alert them the object in front of them, the distance, okay, some other external factors, okay, the number of people behind, surrounding them, okay, the object of traffic light and what's happening with the help of audio and video. So this is more like a multimodal kind of module, right? So these are some of the work that we're doing. And we also have an IoT energy harvester. This is more like using a solar. By using the IoT and solar, we can actually use it to charge our mobile phone, you know, to monitor, to supply power for small appliances that can actually save your electricity bill. Then this is a lake near the faculty. We want to monitor the water quality, okay, water quality of the lake. So we use IoT technology with a couple of sensors that gives us data from time to time, and we try to plot what happens after the rain, what happens before the rain, and what happens during the drought season, right? Some examples. Okay, and this is another project proposal to TPU, Taman Pertanian University. Okay, Taman Pertanian University is doing a flagship project, okay, on kilang tumbuhan, okay, to come up with a food supply. Okay, so to do that, we need to use IoT to monitor the crop status, okay, even the soil status, the temperature, and try to leverage on the visualize their real-time dashboard and to increase their fruit production. Okay, this is just a flagship project. It's still under development, right? Due to the pandemic, I think we couldn't access TPU. Okay, right. So in summary, I think we have seen a lot of proprietary solution. Okay, in the past, in the present, there are also some being developed and pushed, but in future, we hope that the integration will be maintained. Okay, like we want to see the various domain being integrated by realization of Internet of Things, and that's how we can, you know, try to bridge and solve many problems that arises out of it. So these are some research directions in IoT, like interoperability, edge computing, semantic. Okay, like these are more on the computing side. Setup, implementation, and particularly multidisciplinary approach is very interesting. Okay, for example, how we can use IoT in education, for example, and how this computer science domain can help the field of education. It could be probably in the curriculum, content, right? Modules, many more, right? In multidisciplinary approach. So these are the some of the resources of the standards. So a good reading will be IEEE P2413. It's a white paper. It's a standard white paper that could give you some idea about how IoT works. The rest are some materials from the consortiums. Right, so these are some materials from the consortiums. I just put it there, right? Okay, terima kasih, and I'll be happy to get some questions from the floor.
Thank you so much, Doctor. I think we have a question from chat. Hafiz from Hafiz. Doctor, any suggestion on how to avoid this disaster in the attack of cyber attack related to security, I think.
Okay. Yep. How to avoid disaster in the event of cyber attack against connected systems. Okay. One thing is that cyber attack is unpredictable. What we can do is actually we have to do a multi-tiered or multi-level security system, meaning that when you have a multi-tiered, okay, it's quite difficult for cyber attack to take place. Even though, like, I think in the last couple of days we heard about news from that the Japanese government is giving an alert, right? So if we have a three-tiered system, three-tiered of protection, then this could actually reduce the cyber attack against the connected systems, right? So in IoT, okay, IoT for security is very clear. Normally, IoT for security, they are not only talking about the device level, but they also talks about the software attack, right? So this is a very huge, I would say, a very broad topic. But if we want to look into the disaster of the event, we have to look into details of the security domain, which domain we are talking about.
Okay, thank you, Doctor. Question number 2 from Hafiz. Could IoT devices represent a new channel for attack or monetization act?
Oh yes, definitely, because like botnet, IoT can become a new channel of attacks, monetization acts. Okay, we are not know whether it's a genuine IoT device or imposter IoT device in the network. That's why the management and identification of the device is very important. We have to make sure that IoT device registered in the network is actually authenticated and belongs to the organization.
Okay, Hafiz, sila.
Hi. Hi, Doctor.
Yeah, hi.
Okay, because I'm really interested in these IoT things. So actually I got a few more questions, but then I just minimized all the questions. Okay, so my first question actually, when we are talking about the cloud server or maybe the update mechanism, as for example, those older Apple's product such as iPad Air or iPhone 6, for example, maybe need to be upgraded to the latest iOS. So there might be a risk that those devices will not be able to update to third-party apps from the App Store, okay, in future. So maybe we can't use, for example, me myself, I'm using Google Home. So maybe in future I can't use the Google Home afterwards. So it will become another what we call that? Yes, e-waste, right? So what do you think about, or any thoughts on that particular issues? We are talking about the e-waste.
E-waste.
So, and my second question, or you want
go
to
ahead. Wait. Go ahead with the second question.
Okay. So my second question is, just now you are talking about the Bluetooth technology, right? Okay. So IoT, for example, IoT home, basically they are using much more data, such as the smart speakers, they're using voice command, those smart thermostats, and for example, me myself, I'm using all the switches. I've changed all to those smart switch. So is there any methods or maybe positive developments to overcome the internet slow connections problem, as IoT is all about internet? Because from what I've read and from what I've heard, that basically IoT in simple word is things connecting things using internet, right? Okay. So is there any positive development to overcome these issues, or because actually it happens to me, because sometimes I can't connect to my Google Home due to the internet services, as even though I'm staying in Puncak Alam, which is not a remote area lah kot. So, well, you know, there's always ups and downs in using the internet facilities. So just now you are mentioning about the Bluetooth, right?
Right.
So, but then Bluetooth, you need to connect it in a very nearby distance, right?
Right.
So is there any other positive developments to overcome these issues? Okay, thank you so much, Doctor. That's only my question. Thanks.
Right. Thank you, Hafiz, for the question. All right. Coming back to your first question about e-waste. Okay. For personal usage, I think we are using like older generations of iPad, even a MacBook Air. Of course, you have that security risk associated because you couldn't update to the new iOS later because of the limitation of capacity. But for personal usage, it's fine. But when you go to enterprise, there are policies that says that the devices less than 5 years are not available to be connected to the enterprise network. And some multinational companies, normally they will renew their terminals or devices, even routers every 5 years, because of this I would say the patch that's not available for those devices. Okay, so e-waste is there, but it's not that popular. Okay, if you look at in Malaysia, there of course there are awareness on e-waste. How do you manage those e-waste? But at the moment, it's more likely collecting those e-waste, and then we try to channel it to the service providers who wants to to crush it or to recycle it, maybe to donate it to the schools and so on. Okay, it's not in the big scale, a big level yet, but this is going to be a problem because we're going to have a lot of unusable devices, desktops, even laptops that could be 15 years old and so on, right? So the second question about the issues on the internet and also the Bluetooth. Okay, you see the earlier generation of Bluetooth was actually as you said, there was a limitation because you can only connect within 100 meter radius, right? 100 meter radius. But what happened with BLE 5.0, the new version, they are available for mesh networking. Mesh networking meaning that you can actually connect all your devices in mesh level. So that means how does the mesh work is that it actually connects the device to the shortest part of the network. So there are a lot of things to be explored in the BLE 5.0. In Malaysia, we are seeing a lot of devices or even appliances now supporting BLE 5.0. Okay, so it will take some time, to maybe another 5 years to get to see the maturity of the devices. Okay, but about the connectivity issues, of course, when you have a lot of devices, it's always a problem. You might, as you mentioned, you might have this issues of connectivity, right? But BLE is expected to overcome this in near future. It's something to watch out. Okay. Right, thank you.
Okay, kawan-kawan lain ada soalan? Kalau tak ada, saya nak tanya.
Yang Bluetooth tu saya ada satu betul. Dr. Tina, saya tengok dia lebih kepada cost efektif untuk operation kan, Dr. Tina, sebab contohnya kita nak buat untuk pertanian. So nanti macam kita nak takkan petani tu dia nak pakai dia punya sendiri mobile data dia ke, dia punya internet tu just nak untuk operation of dia punya harvest kan. Contohlah.
Turn on tali air pun just guna Bluetooth. I think it's okay.
Ya. Dan satu lagi saya tertarik dengan yang when you said about yang culture tu kan ataupun society punya tu. So kalau nak jadikan IoT ni berjaya, saya rasa memang kena work very closely dengan the owner of the process lah. Sebab the owner of the process je yang tahu, yang pakai ataupun yang dah biasa dengan katakan manual ataupun biasa punya yang proses kan. Yes. Only that, then orang yang the IT people can come in and then to work together untuk faham yang you kata problem statement tu lah.
Betul. Kena work together dengan domain.
Ya. Untuk tentukan domain dan sebagainya kan. So yang ini yang saya rasa nak bagi understanding of both side of people, dan juga kalau enterprise level, dia kena faham dekat enterprise level tu apa keperluan tu kan.
Betul.
Dan menggunakan standard yang sesuai lah untuk to make this IoT works.
Right.
Okay, orang lain soalan.
Doktor, saya nak tanya.
Yes, yeah.
Tadi Dr. dia mention di peringkat degree ada diajar Arduino dan Raspberry Pi kan.
Yeah.
Saya pun ada explore lah Raspberry Pi ni sebagai kata apa, saya gunakan untuk buat create private DNS untuk control saya punya internet content anak-anak ni. Selain pada router lah, router kita boleh cloud kan. TP-Link kita boleh cloud dia mana-mana, nak on off, nak tengok, nak sleep ke apa. Saya guna juga Raspberry Pi. Cuma saya nak tanya doktor, sesuai tak kalau sebab di peringkat primary school sekolah rendah dia belum ada IoT, setakat coding, block coding untuk robotik je. Sekolah menengah saya tak pasti, tapi sekolah saya rasa sekolah menengah dah ada lah dia punya intro kan. Cuma sesuai tak kalau kita nak bawa Raspberry Pi ni ke dalam silibus ataupun sebagai add-on dalam sukatan untuk sekolah rendah ni?
Sekolah rendah ni I think saya rasa Raspberry Pi still high level. Dia masih tak sesuai lagi. Tapi untuk sekolah menengah still okay, tapi untuk sekolah rendah kalau saya rasa paling Scratch is more than enough actually.
Dia ada tak apa cadangan untuk macam mana IoT yang sesuai untuk sekolah rendah?
Kalau IoT kita boleh guna I think microbit. Pernah dengar microbit?
Pernah dah.
Microbit I think sesuai untuk sekolah rendah. I think kita boleh blend dengan kurikulum yang sedia ada.
Okay.
So sebenarnya platform tak ada masalah, cuma how we use the platform to suit the current curriculum. Sebab dia macam Arduino, even Raspberry Pi, maybe another 5 years dia takkan ada dalam market. Mungkin ada platform baru. So mungkin yang kita kena tengok ialah the content of the curriculum. Does it really suits the level of the students? Kalau okay, then kita boleh try to see platform, or we can have our own platform. Tak masalah.
Okay, terima kasih. Thank you, Dr.
Yang kurikulum sekarang yang ada ni di cover ke untuk basic knowledge untuk nak sampai all aspect of apa yang Dr. Tina cakap sekarang ni? Sebab saya tengok macam event management pun kan. So macam mana doktor kalau you tengok kurikulum yang ada sekarang?
Untuk sekolah ke doktor? Untuk sekolah rendah?
Sekolah. Ya, sekolah dan dari segi macam universiti pun saya tengok macam tak konsisten juga.
Ya, because
so
ada clear guideline pasal IoT ni sebab dia bidang baru. And then bila kita tengok roadmap IoT 4.0 dengan STEM punya plan pembangunan pendidikan dalam STEM tu memang ada dimension, tapi it's very difficult to bring the platform tu merge dengan current curriculum. Sebab our current curriculum ni still
the learning block tu macam tak clear kan Dr.
Ya,
Tina?
betul, learning block tak clear, betul. I agree with that. Betul. Learning block dia tak clear.
Ada soalan yang lain? Ada soalan-soalan yang diperlukan untuk Dr. Tina jawab? It's very interesting topic today. Just tanya je. Bukan senang nak dapat Dr. Tina untuk bercakap. Dr. Tina.
Boleh. Anytime.
So Dr. Tina ada tak maknanya research yang terkini ataupun yang tentang IoT lah yang rasa macam tadi doktor dah cadang kan, disiplin apa yang boleh explore, domain apa yang sekarang lah maknanya kongsi sikit lah, maknanya kalau kita nak search nanti tengok paper apa yang terkini tentang IoT research yang di Malaysia lah, konteks Malaysia.
Konteks Malaysia kita lebih kepada smart city, masih dalam smart city, tapi problem dekat Malaysia sebab kita majlis perbandaran, majlis local council, dia tak sah haluan. So susah nak macam kalau you pergi kat Sepang di different requirement, and then if you go to Kajang is different requirement, if you go to Subang Jaya is different requirement. So susah nak interoperate. So maybe boleh lah, I mean kalau nak buat dekat Sepang, I think it's okay just for Sepang, but not for Kajang. You cannot integrate together. Tapi the focus kat Malaysia saya tengok lebih kepada smart city.
So in term of macam integration tu kena dekat polisi jugalah kan?
Polisi, yeah. Finally kita
policy.
Kena we have to oblige to the policy. Yes.
Ya. Saya involve dengan IoT ni bila working dengan untuk bidang pertanian jugalah kan, which yang crucial ni kita punya food supply kita ni. let's say beras lah, cukup beras kan. So manually kalau tak ada IoT ni kita beras ni very sensitive dengan suhu kan. So IoT ni very much fit bila kita dapat tengok the real time of processing padi tu mengikut temperature yang sesuai, otherwise dia akan break, dia akan pecah dan kualiti turun. So sedangkan Malaysia ni patut memang kualiti beras kita memang bagus daripada negara lain di Asia Tenggara. Tapi sebab kita agak lambat untuk take up IoT ni, so banyak wasted lah. So the only people yang understand the process of nak proses beras padi daripada padi sampai ke jadi on our plate tu yang the challenge lah. So this is one example yang saya nampak yang bila Dr. Tina cakap pasal challenge tu lah. Sedangkan dia sangat boleh membantu kan. You bayangkan kita petani dapat tengok dekat handphone je.
Betul.
Kan? Sekarang ni dia tengah proses untuk pecahkan untuk buka nak boleh jadi padi tu jadi beras yang dalam kualiti yang nak, dia punya proses tu berapa masa lama kan, dah sesuai untuk shut down the process of live tu kan, yang macam live data push tu semua tu kan. So processing tu yang ada kaitan tadi tu dengan network dan juga cost lah, nak pakai Bluetooth ke apa dan sebagainya. So banyak sangat perkara yang sebenarnya yang terlibat lah. IoT tu bukan simple macam tu je lah. So
sebab kena engage dengan domain expert. Baru kita
domain expert, yes. Tapi yang pendidikan ni saya pun fikir jugalah kena tengok kat operation level yang akan cost benefit lah. So tadi nampak macam contoh nak kalau bangunan sekolah yang banyak kelas, banyak pakai aircon katakan kan, how to control automatically from your handphone. Lepas tu mungkin attendance, keselamatan pelajar kan berada di dalam sekolah. Other than that tu lah macam khusus lah, tapi badan khusus pun sebab integration tu tak ada, LMS masing-masing, sistem macam-macam, tak ada integration. So domain berbeza-beza, so susah jugalah nak sampai ke tahap apa yang kita nak tu.
Dia memang masa. It will happen but it will take some time.
Saya nampak ada soalan tu. Apa soalan tu?
Okay, boleh kajian pasal IoT di sekolah. Contohnya guna wearable device untuk rekod body temperature murid. Okay, I think memang dah ada cadangan nak buat macam wearable device untuk ambil temperature, but it's a very straightforward application. Contohnya dia macam guna beacon tu, tapi masalahnya how you want to use that beacon on the student, where they going to place the beacon, is it going to be part of their
itulah kalau beacon tu macam budak sekolah kita pun dia tak pakai even card pun, student card kan.
Betul,
student card ni budak universiti je, so beacon tu you nak hang kat siapa kan. Nak letak kat mana,
mungkin kurang sesuai untuk beacon, or maybe kita kena find another.
So kalau harga dia pun pula berapa, dan kalau hilang tu kan, so ikut juga kalau budak universiti pun boleh hilang, apa lagi budak sekolah. So banyaklah challenge untuk ni beacon. We buat beacon pun untuk nak test out untuk student universiti masuk future classroom tu. But then itulah kita tengok dengan harga pun macam benda tak. Tapi you cakap tadi kan macam patutnya chip-chip tu semua murah sebenarnya. Kalau kita ada control, some sort of mechanism untuk control harga, barulah rasa IoT ni laju sikit. Tapi bila kita tak ada siapa yang look into prices dan sebagainya, tu yang jadikan benda ni slow kot.
Exactly, betul.
Doktor, Bluetooth Bluetooth 5.0 BLE tadi tu kan, the Bluetooth 5.0 it still can be connected to those older Bluetooth like Bluetooth 4.0, right?
Yeah. Backward compatible.
Okay, thanks.
Okay, dah 11.46. Kalau tak ada apa-apa soalan lagi, kita mengucapkan berbanyak terima kasih sangat kepada Prof. Madya, Dr. Thinagaran kerana sudi datang untuk berkongsi ilmu dan kepakaran dalam bidang IoT ni. hopefully ini akan memberi semangat kepada pelajar untuk mencari lagi maklumat dan juga kembangkan lagi knowledge you dalam IoT ni, supaya when you being referred to, bila you balik kerja nanti adalah sikit ilmu tu kan. So don't stop learning, dan kita sangat bertuah lah sebab dalam UPM ni kita ada macam-macam fakulti yang sebenarnya boleh provide you with the knowledge. So continually sepatutnya kita sentiasa adakan sesi-sesi macam ni supaya kita boleh buat sharing, dan lepas ni hopefully we can beri pula student beri pula you punya knowledge dan understanding ni kepada sekolah-sekolah pula, pada guru-guru dan sebagainya, supaya saya rasa kita dapat mempercepatkan Malaysia ni in terms of how we integrate teknologi dalam kita punya kehidupan harian lah, for a good cause, for a good advantage dan sebagainya. So it's all about knowledge, dan you all bertanggungjawab untuk giving the right knowledge to the schools and the community dalam education lah. So terima kasih Dr. Tina. Dan kalau kita ajak lagi boleh. So siapa yang pelajar baru yang berminat dengan Dr. Tina untuk supervisor, co-supervisor, bolehlah merancang-rancang topik yang bersesuaian dengan Dr. Tina. Boleh Dr. Tina?
Boleh.
So sekarang ni dia supervise untuk Mazlan. So hopefully lepas ni ada lebih lagi lah, ramai lagi lah. So terima kasih banyak-banyak, dan we'll keep in touch lah untuk kita punya projek Smart Classroom Dr. Tina.
Sure.
Doktor, sebelum kita akhiri, kita tolong terbaik untuk switch on kamera sebab nak ambil gambar. Boleh tak?
Saya tak payahlah.
Yang lain lah, yang boleh lah.
Yang lain nanti.
Selain daripada attendant tadi kita ambil ni. Okey, minta tolong kawan-kawan switch on kamera. Hafiz selain daripada dia tukar IoT device dalam rumah dia, muka dia pun tukar kepada anime. Okay, ready ya? Subah tak ada ini, tidak ada hijau. Okay, kita tunggu lagi. Sekejap. 1, 2, 3. Lagi sekali. 1, 2, 3. Okay, thank you. Terima kasih semua.
Terima kasih.
Terima kasih semua.
Terima kasih Ustaz Lan.
Terima kasih semua.
Terima kasih Dr. Tina.
Terima kasih semua.
Thank you Dr. Tina.
Thank you.
Terima kasih Dr. Tina.
Terima kasih.
Wah, background Dr. Lan. Dah upgrade ke belakang tu?
PC baru untuk anak.
Oh, tak anak. Menarik.
Okay, Wan, nanti sembang.
Okay. Right.
Okay, terima kasih banyak.
Okay,
Nanti Ustaz Mazlan, kita share link nanti kalau siapa yang tertinggal tu dia boleh tengok balik. Kita
boleh. Okay, nanti saya share link.
Nantilah kemudian.
Okay, baik.
Okay, terima kasih Tuan Mazlan.
Okay, sama-sama.
Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh.